So in this example, it says, in the standard xy coordinate plane, how many times does the graph y equals x times 1 times x plus 2 times x minus 3 times x plus 4 times x plus 5 intersect the x-axis? All right. So one thing we need to remember is what are some things that we looked at as far as the shape for polynomials and or for quadratics. So let's go through, or just polynomials, don't need to get a quadratic. But what I'm going to do is I'm going to give you an example of a quadratic to kind of go through what exactly, how do we determine where they intersect. So let's just do the quadratic y equals x squared minus 4. All right. Now, hopefully you guys can visualize that graph where you know that the parent graph of just x squared looks like this. Yes, if you guys remember that. And then if I was just going to simply minus 4, which we're going to kind of be working on today, that's just going to shift the graph down 2 units. 1, 2, 3, 4. So now I take that graph and I plot it here with my new vertex. And it's going to intersect at 2 points, right? It intersects the x-axis at 2 points. Now, how do we determine what those 2 points are? Well, it's very important to understand that at where they intersect, right here, those are 2 coordinate points. I don't know what the x-coordinate is, but I do know what the y-coordinate is. And Lee, what is going to be the y-coordinate at each of these points? No, right here. 0. I don't know what x is, but I know y is 0, right? Because here, y equals 1, y equals 2. Here, y equals negative 1, y equals negative 2. So on the x-axis, y is equal to 0. Does that make sense? So to find those values, what we did is we plugged 0 in for y, and we said x squared minus 4. Now, you could obviously add 4 to both sides and take the square root of. But the other thing that we learned was to apply factoring. And you can factor this using the difference of 2 squares. And the reason why factoring was so helpful is because when you have a product equal to 0, right? When you have a product equal to 0, then either one of these now have to equal 0. So we set them both equal to 0. And we said x minus 2 equals 0, x plus 2 equals 0. So therefore, x equals 2, and x equals negative 2. So that means those are the values for where they both intersect. So what we can do is we can go back and say, oh, each one of these factors is what we call a root. It provides a root or an x-intercept or a 0. It produces, this is where each one of these values or these factors produces an x-intercept. So now let's go back up to our original problem. Well, how many of these x-intercepts, Laurel, Tiffany, do we have? We have 1, 2, 3, 4, 5. You could have just counted the number, and you would have had the correct answer.